Hey everyone, this is Daniel, and today I have another long form conversation for you. And today my guest is Richard Feldman. He is a software engineer for more than 20 years. He's a book author and frequent conference speaker, and he's the creator of the Rock programming language. ROC, and he's also a major contributor to Zed, the AI enabled code editor. And we have a wide ranging and fascinating conversation about a wide variety of technical topics. We talk about Rock, of course, and how it wants to overtake Go in systems programming, about architectural decisions that make Rock distinguished from programming languages of the same kind, about functional programming and how Richard very carefully and skillfully avoids ivory tower naming like the famous M word and so on and so forth, and many nitty-gritty details about Zig, about Rust, and many other things. We also talk about teaching and speaking and some career advice, and obviously about AI and productivity and holding control over your code. So without further ado, please enjoy a fascinating conversation with Richard Feldman. Richard, thank you so much for making the time. It's great to have you.
Yeah, thanks for having me.
All right, so we're going to talk about Rock, of course, but I want to talk about Rust for a moment. And
Okay.
specifically, I wanted to talk about Rust's memory safety and the fact that its memory safety is one of the features that drove much of the adoption of Rust. But for you, it somehow seems to be not that applicable. Can you tell us why?
I don't know if I would say that it's not that applicable, but rather, so this is in the specific context of Rock's compiler.
Yes.
Um, so it's not so much that I would say the memory safety isn't applicable, but rather that the types of problems that Rust's memory safety model solves are not that helpful for this particular code base, or at
Hmm.
least I don't think they are. Um, so Rust memory safety solves addresses two major categories of problems. So there's the borrow checker, which is sort of the more famous one, and then there's the less glamorous, more kind of nuts and bolts. Like really, any language could do this. It's just like C and C++ don't or don't by default, which is just bounds checking. So this is like if you have my array brackets 0. In C, that's unchecked. If the array points to some uninitialized memory, it's just going to go and read it. Whereas in Rust and in Zig, you have this concept of balance checking where it's like, oh, okay, well, I know how long this thing is. It's not just a plain pointer. And so you can verify that and either panic at runtime or return a result or something like that or an option. Um, so importantly, the borrow checker is the part where that's where it's not as useful to me. So the borrow checker's whole job is to manage lifetimes, and the two particular memory safety issues that it prevents are use after free and double free. So this has to do with like if you've got a whole bunch of different lifetimes of things. So Zed is actually a good example of this. So Zed's like a graphical code editor. You're creating and destroying things all the time. It's very, very like not process oriented. You're opening panels, you're closing panels, you're opening files, like language servers running. It's just chaos. There's tons of allocations happening, and you need to deallocate as eagerly as possible so that you're reclaiming memory and all of that stuff. I think Zed benefits tremendously from Rust having this sort of automatic memory management, and also its reference counting system, like automatic reference counting. Zed makes a ton of use of that. Um, in contrast, Rock's compiler is designed to be like a lot of compilers, just very sequential. It's like we do parsing and we do canonicalization, we do type checking, and then we do there's some various like stages to the back end like code generation and whatnot. And each of those, the lifetimes are very simple. It's just like how long does this memory need to live? It's the answer either until the end of this phase or until the end of the entire compilation process. And those are the only real two answers there. It's not like, oh, we're bouncing in like making allocations. We got to deallocate them all the time. In a lot of cases, it's like you don't really need to deallocate that. It's like it's
Hmm.
fine. Let's just leave it alive, and we'll clean it up when the entire compilation pipeline is done. Um, and that's even true if we're doing sort of like a real time like watching the file system for changes, or like a language server type thing. It's still very process oriented. So you can say like just make an arena, and this is what we were doing in the original Rust implementation of Rock's compiler. We'd like make an arena allocator using the Bumpelo library, and then say like, okay, this is how long this memory lives for, and then at the end of it, it gets thrown away. But actually, a pain point that we had in Rust is that Rust's standard library collections are not really designed to be used in that way. They want a sort of global allocator that they can assume is just going to do allocations and deallocations whenever they want. And it was actually annoying because culturally in Rust, you don't really see like, oh, let's assume that I'm going to be passed an allocator that's going to be for just this one lifetime that we know ahead of time and is very easy to define. And so we would have to be kind of like working around that. Whereas in Zig, it's the other way around. In Zig, you give everything an allocator, like everything, a standard library and the entire ecosystem. It's always like, give me an allocator, and you can just say, here's my arena allocator. Like, okay, and you have a lot of confidence that nobody's going off and doing their own, memory management thing off to the side with some like global allocator, because that's not just how things are done in Zig. Um, so in those cases, it's like use after free and double free. It's like our lifetimes are very straightforward. We just don't. That's not a real pain point that we have. So yeah, to answer your question directly, like it's not so much that Rust memory safety is like I don't think it's valuable or anything like that. It's more that for this particular project, it just wasn't a big selling point because the problem that it solves is just not a big problem we have.
How has the experience been with Zig? So you've uh, written a version of the rock compiler in Zig. How has that experience been compared to Rust?
I mean, overall, it's been a great experience. If I compare it to Rust, there are definitely some things that are better and some things that are worse. Overall, I would say we made the right choice by switching to Zig. Nobody's had like buyer's remorse and has been like, oh man, we should have gone back to like that. That has not happened at all.
Hmm.
Like no contributor have I heard that from. Um, Having said that, I mean, the main thing that I will notice that happens more in the Zig version of the compiler compared to the Rust version of the compiler is that we will get from time to time, like memory safety type errors, like segmentation faults specifically.
Right.
So we have not seen like memory corruption errors. I mean, maybe I don't know, there might have been one or something like that. It's a little bit tricky to disentangle. Like, are these coming from within the compiler, or are these because this is a compiler and we generated code? Like, the compiler outputs machine instructions, and those, of course, are completely unsafe. And so those can cause segmentation faults. So when I'm seeing a test run and there's a segmentation fault, it's like, wait a minute, is this our compiler seg faulted or the compiler generated something that's seg faulted? But we have definitely seen some where it was coming from within the compiler. And also there's been some cases of like, this is an explicit memory leak where, despite the lifetimes being relatively straightforward, we just like allocated something and forgot to free it at the end of any of the phases. So even though it was like easy to figure out when to do it, because Zig doesn't do that for you automatically and Rust does, the symptom is instead of like in Rust, the symptom, well, actually Rust might have just taken care of it, but in Zig, it's like we get a test failure saying like this test leaked memory, like you allocated this and you never deallocated it. So that is one of Zig's features, is that like every allocation needs to come with a corresponding deallocation, or else the test will fail when you're using the testing allocator. So those are things that like we didn't run into in Rust. They haven't been a big deal. Like it's been like a minor hiccup, but it's like a concrete downside of something where I'm like, yeah, this would not have happened in Rust, but I'm still happy with the decision overall because all these other things have been nicer.
What I wanted to ask about the purpose of rock, and I wanted to avoid the very simple why rock question, but uh, I wanted to get to a flavor of that, which is the kind of problems that you saw rock solve in practice that uh, alternatives did not or could not.
Yeah, I mean the short version of that is that it wasn't one particular thing. It was more about honestly, like one of the things that came to my mind. It's funny because this was so long ago that it was a big deal at the time, but now I'm sort of like, whatever about that particular use case, which was Vim script. So I was a longtime Vim user, and I'd always thought like, I'd really like to write a Vim extension for this, but I don't want to learn Vim script. I don't. It has a really bad reputation. I don't want to learn it. I don't want to like use it. I think I'm going to have a bad experience doing that. And yet there's like a Vim extension that I would like to write and author and like to exist. These days, you have NeoVim has like Lua, and that NeoVim existed, but it didn't have like the Lua support back then. This would have been like 2017, 2018. And I remember thinking like, if I had a nice Elm-like language, like Elm being the language that at that time I was like working full time in, wrote a book about it, like super into Elm all the time.
No, that's about
I was
it.
like, I really, yeah, I was like, I really want an Elm like language for use cases that are outside of Elm's specialty of, being like for building web apps, basically. I'm like, Vim script, there's no way there's ever going to be like Elm compiling to Vim script, right? That's never going to happen. It just wouldn't make sense for Elm as a language. But there are a lot of use cases like that. There's also like robotics and, obviously command line apps, native desktop apps, mobile apps, command line apps. There's just all these different types of things that you can build software for. And Elm's focus on being like, this is going to be a really complete, coherent design for one use case doesn't really jive with wanting to have some kind of an Elm like experience for this really long tail of use cases. They're sort of fundamentally at odds. And so what I decided was I was like, why don't I build a language that is Elm-like and has the characteristics that I like about Elm, but which is not as focused. So it can't be like that platonic ideal of like as good as possible at that one domain, but it trades that off for being able to be at least a much better experience than like a Vim script, for example, at a very long tail of domains. So that was the problem that I wanted to solve with Rock.
And do you anticipate that sort of problem space to be, I don't know, better served by Rock than anything else? Are there others?
I can't name anything else that is. I mean, of course, Rock being a pre O.1 language, although this year we're anticipating finally being ready to launch it with the new compiler. I can't be like, oh, Rock is better than Go, for example, for servers. That doesn't make any sense. Like Go is
Hmm.
extremely mature, has a huge ecosystem, yada yada. Um, but the goal is that, like, yeah, no, I mean, for example, we would be better than Go for servers, like for web servers. And we can go into details on like specifically why I would make that claim. If Rock has like realized its ambitions in the way that Go has, just from a design perspective and like what the foundational characteristics of each language are, I think Rock could be better than Go for the things that Go is the best at right now. Um,
That's a
and I think the
bold
same would
statement.
go. Yeah, well, I mean, we're aiming high, right? This is
Hmm.
not like it's not a toy language. I'm not trying to just like make a little, hey, here's my language, right? It's like we want to like solve real problems and really like advance the state of the art. Um, like Go was, coming up on like 20 years old, something like that,
Hmm.
approaching that. So, if we can't come up with something better than that, then I don't know, as technologists, are we doing a great job? um,
That's fair. Yeah.
and I'm picking Go because one of our big goals is to have really fast compilation time and really fast runtime performance. And Go is, I mean, arguably the language that is the best at both of those at the same time. You have lots of languages that are faster at runtime, but a lot slower to compile, like Rust. Um, Zig, I would say, is maybe one of the other languages that's like that. But of course, Zig is not automatically memory managed like Go is and like Rock is. So it's kind of in a different category. But yeah, I mean, it's definitely we're aiming high. We want to make a language that is really good for that. Lua would be another example in terms of being a language that's good for making little like extensions and things like that, where you have a really locked down sandbox in terms of what it can do, and you can trust really well, like that you're running it, and it's like I don't even need to look at the source code. I can just look at one line of configuration and be like, yep, no, I can. This is not going to mess with my computer at all. Dino would be another competitor. So Dino has this sandbox scripting mode where you can like download a .ts file and run it through Dino, and it can make certain guarantees about like, oh, it's not allowed to use the network without your permission. Rock can also do that. And I think we have we can make stronger guarantees, I believe, than Dino can around like what the code you're running can and can't do, again, without having to look at the entire thing. Just look at like one line of configuration. You're like, okay, cool. I can see what this is capable of, and I'm not worried about it. Um, so yeah, I can go on and on.
Why do you say that, or I wanted to pick up on that bold claim of yours, and can you give us more details about why do you think that Rock can be better than Go at something that Go is and has been historically great at?
Yeah, sure. So the baseline, I can give you some like very quick bullet points of like why I think Rock could be better than Go for our web
Hmm.
servers. Okay, so why is Go good for web servers right now? I would say a couple of things. One is it compiles fast. Another is that it runs fast. Another is that it has this really nice deployment story where you can just compile to a statically linked executable and just like copy it right up to the server with cross compilation. Rock today already has all of those things. So check. So that's on par. what are some other things that Go has? Go is famously a simple language. Depending on who you ask, that like is or is not an accurate statement about the language's design, but maybe more accurate about its implementation. I don't know. Um, but it's certainly something that people like about Go. Rock also a language with a simple design. Which one is like simpler? I don't know. That's probably a matter of taste, but I think they're both people would a lot of people would agree. I think they're in the same kind of ballpark. Okay, so then moving on to like what sort of sets them apart. Well, one thing that Go has famously is it has this concurrency model that does have data races. So you actually can get memory unsafety in Go without using FFI, without using any third-party stuff, just from the way that I believe it's interfaces and Go routines, like how they interact in a way where you can have data races and like memory can just get corrupted if you're just using the language totally normally. Rock doesn't have that. Instead, what we have is like immutability by default. So Go also doesn't have immutability by default. Go also has this problem with defaulting to zero if you don't like specify things. This is like a source of error prone things and bugs and whatnot.
It's a
Rock
flavor
does
of
not have
null,
that.
right?
Yeah, right. Null, sure, is another one. Rock doesn't have null. And then of course people always complain about the error handling in Go and how like the error handling in Go is like really like if error not equal to nil, blah blah blah. It's just it's total meme on the internet. Rock has great error handling. It has the nicest error handling of any language I've used, with the possible exception of Zig. They have like little trade-offs, pros and cons. But I mean, very briefly, it's like Rock has first-class sum types, so like algebraic data types. I know a lot of people probably Scala are familiar with this. These are like in the ML family tradition of languages, like Robin Milner's meta language, ML, not machine learning, where you have or Haskell, like algebraic data types. But we have anonymous ones. So what that means is that basically you can say, I'm going to just create, like define a new name for a new error type without having to say, here is every single possibility. And what that does is that means if I have, let's say the classic example I like to use is, let's say I'm doing a file read, and then I'm doing, I read a URL out of the file, and I do an HTTP request with the contents of that file that I just read, and then I get back the response, and I want to write that response to another file. So these are three different I/O operations, and all of them can fail in different ways, right? Read file, HTTP request, and write file. So in Rock, what will happen is that basically I do all three of these. What I end up with at the end of that is I end up with a type that just says, here's all the different errors that could have happened across all those. They just get aggregated. And I can just do a pattern match on that, and it's exhaustive, meaning if I leave out an error that could have happened in one of those things, I'll get a compile time error. And yet I'm very precisely saying, like, here, if this error happens, this error happens, if this error happens, here's what I want done. But it's pattern matching. So you can also be as granular as you want or as non-granular as you want. You can just do an underscore and be like, handle all the errors the same way. So it's sort of like all of the best parts of like using values for error handling, such as like result or option or maybe depending on your language. But you don't have any of the like sort of baggage of having to like explicitly enumerate, here's exactly all the ways that this batch of operations can happen up front. That just happens for you behind the scenes in the compiler. This is a very far cry from Go's famously painful error handling. It's almost like Rock's not famous, but but if it were, famously unpainful error handling.
That sounds like amazing developer experience. And I went through the Rock documentation, and first of all, it is a simple language in the sense that you get the main principles relatively quickly. So as a Scala developer, I could very easily map Rock concepts to what I'm currently familiar with, and
Nice.
so that's a +1 to the documentation. I also saw the error handling thing, and I do have to commend you on this one because it is great. And the sum types for errors for composite operations does look and handle great. So yeah, that's a major selling point. I wanted to ask about the success of Rock. So you said you're aiming high.
Yes.
Where is that? How would you gauge success for Rock?
For me, success mostly means like people are making good software with Rock, and like a lot of people. So if one person makes a really great program with Rock, that's awesome. I'm very happy about that. But I can't say the language has succeeded. I think for it to have like really succeeded, it needs to be that a lot of people are using it to make good software. And I want to caveat that good software or like underline that. Like if a lot of people are using Rock to just like crank out nonsense or just like make silly throwaway scripts, I would not feel like it was a success. Like the goal is that people are using it to make like high quality software that end users enjoy using, and like people are like,
Hmm.
oh, this is like good software, and it turns out it was made with Rock, and maybe they can't tell other than the fact that they're like, oh, it's good. And maybe in the same way that some languages, which I won't name because I don't want to just randomly throw stones here, but like sometimes people use it and someone's like, oh yeah, well it was made in blank, and someone's like, oh, that explains it, right? Like the
Hmm.
opposite of that, right? I don't want people to be like, oh, well, it was made in Rock, that's why it sucks. The opposite of that. It's like, oh, this feels really nice and snappy, and it doesn't feel buggy. It feels like just high quality software. And someone's like, "Oh, it's made in Rock." Like, oh, that explains it, right? That's what I'm more going for. But I mean, I do just to, I mean, really directly say this. Like, I do think adoption is an important part of that. It's not just enough for me to be like, I would not consider the language a success if it's only ever used by a small group of people, which it currently is. But pre 0.1, like hoping to announce an 0.1. Eventually, we'll go to a 1.0. But in the fullness of time, like once it's been out there for a while and like people have had time to use it and have more and more success stories, hopefully, yeah, that's how I gauge success.
That's it seems that, I mean, this is a pretty loose definition, but I'm pretty sure that you have it clear in your head. And I think you have it clear in your head because you have a lot of experience using a variety of tools and you know what's good and what's not. And you want people to feel the kind of feeling that you have when you're using a good software tool, a good library, a good language, a good programming tool. So I think I understand that. And most of this audience listening to this right now, I think will understand. At the moment of this recording, most of this audience is mainly Scala developers, and we are generally quite fans of Scala as a programming language, a thinking tool, and we also have this attachment to what good software is and what a good tool is supposed to do for us. So I empathize with that. I wanted to pick up on the adoption thing also as a self interested question because I'm mostly in the Scala space
Hmm.
and there has been there's been an ongoing debate for a couple of years at least about Scala adoption. And there's always a chicken and egg problem of either companies need to pick the language before the team or the whatever core development group can develop the language and make it like widely adopted, polished with good developer experience, good IDE integration and whatnot to get funding and whatnot. And vice versa, the companies will not adopt a new language unless they already have a good developer experience, good IDE integration, and stuff like that, and also a good track record, especially um, for important code that Rock wants to be a decent part of. So I wanted to ask you how you imagine growing the adoption of Rock in a space where people want to see results first, I would say. I mean, specifically for good software, important code, critical pieces
Totally.
in a big system that's not vibe coded or whatever. Um, what's your take on that?
Yeah, so I would say there are two pieces to adoption, and I see them as sort of different stages. At least in Rock's case, I don't know about every language has its own story about how it gets adopted.
Hmm.
Whatever language is popular today, there was a time when it had 0 and then 1 user, right? So they all managed to get big somehow. So how did they do it? And it varies by language, but I think in this day and age, the most common path for a new language to get adopted is through startups. So the pipeline is that you have okay, I'll take an example. Why is PHP a gigantic code base at Facebook? It's very simple because the guy who happened to found Facebook happened to choose PHP, and then that company got huge, and so everybody who joined kept adding to that code base that that one guy started. Um, why is Rails huge at Shopify? Very simple story. There was a guy who started Shopify. He chose Rails, and then everybody he hired kept adding onto that Rails code base. And now there's a huge Rails code base at Shopify because Shopify got huge. So you can see the pattern here. It's like you have one person who maybe is just like a hobbyist, right? Mark Zuckerberg was using PHP as a hobbyist before he started Facebook, and it was originally a hobby project. Same story with Rails and Shopify. Same story with lots of things. It's like people are like, "Oh, I'm starting my own company. I don't have a boss to tell me what language to use. I just get to pick whatever I want, and I picked blah. I'm going to use blah because I like using blah outside of work. And then some percentage of those startups fail, and some percentage of those startups get huge. And guess what? If someone picked blah and they get huge, now there's a huge blah code base out there. That in turn is social proof for other companies to be like, oh, blah is not risky because look at this gigantic $1 trillion company that uses it,
Hmm.
right? Plus, along the way, as that company is getting huge, they're working out all the kinks and bugs and like figuring out like how do we scale this thing and blah 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 and writing blog posts and hiring experts to like improve the tooling and all that stuff. Um, so it's not like it's just social proof, but uh, I think it starts with the startups. It's just you get hobbyists who go on to start a company and then some of those companies get big. That I think is the pathway. That
How
takes years. It's
how
not
do
it's
you
not an
approach
overnight thing.
them? I mean, this is a. I mean, you probably need to train people to use Rock first. You probably need to be one of those people to start Rock startups. I'm imagining where some people in your core team that then get to spread and teach this thing. How do you? What's your take on this one?
I mean, I don't see that as something that I proactively do. I think it's something where you just encourage your community of hobbyists and then just assume that like some percentage of people are going to start a company. Some percentage of those companies are going to be successful. Um, you don't really get a whole lot of control over that. But what you can do is like the people who come and show up and want to use your language, you know, even if they're not using it at work, you can just recognize that like there's a pathway to having a thriving community of hobbyists who are just using it outside of work, who end up someday using it at work through one way or another. Um, there are other paths that can happen though. Like so when I was working at No Red Inc., I specifically remember this. I was at an Elm meetup in San Francisco, which was the only Elm meetup in the world at the time. Um, I was like walking back to my apartment with Evan Chaplicki. We both lived in a similar neighborhood, and so we were walking back together and chatting. And I remember saying to him, you know, I work at this company, No Red Ink, and we're a small startup, so this is never going to happen here. But someday, I would really like to use Elm at work. Now, fast forward like a year or something like that, and one thing led to another. We did end up using it at that company. It actually ended up being the largest Elm code base in the world. I don't know if it still is, but it certainly was for a while. Um, but like that just happened because I was an excited hobbyist, and we ran into a problem at work, and I thought Elm would have been a really good choice for this. I really wish I'd used Elm because I knew it was there. And it would have solved our problem. And I was like, whatever, I'm just not going to make that mistake again. I introduced it. My coworkers were like, cool, let's try it out. And one thing led to another, and we just had a giant Elm code base. And so that's a way it can happen too. But again, it just started with a hobbyist, in this case, me. So I've seen that pattern play out not just in the famous examples like Facebook and whatnot, but just in smaller examples of people who they like the language, they're using it out in their spare time. They really think I would love to be using this at work, and they figure out how to get from where it is to how it can make sense in their job. I would imagine, I don't know this for a fact, but I would imagine that a whole lot of Scala adoption stories started that way too, where it's like somebody's using Java at work, they're using Scala at home, and they're like, I bet I could sneak some Scala into my code base at work because the FFI is so easy, right? It's interrupts so easily with Java. And so, one thing leads to another. So that's, like I said, every language is different. But I think in the case of Rock, I hope that we can use somewhat of a Scala-like story because Rock is designed to be very, very easy to embed in other languages. It can't be as seamless as Scala where you have like literally you can just import Java code and
Hmm.
like write Java syntax and stuff like that. Use it as like Java without semicolons because the semantics are different. But in terms of like the FFI boundary, it's designed to be very easy to like interoperate with other languages and make that boundary really small and make Rock a very good citizen where it doesn't have its own like stateful virtual machine that you have to spin up. It's just like it's as easy as adding a C library, which basically every language has support for like doing that under the hood in a really seamless way. J and I or whatnot. So we actually have in the Rock repo we actually have little examples of like they're all like hello world level, but it's like, hey, hello world from Scala, hello world from Java, where like the hello world part is in
Hmm.
Rock. Because yeah, you can just embed it in all sorts of different things. So that's kind of our plan for once we have a community of hobbyists that are sufficiently motivated to use it at work. I should note we have had people use Rock at work in very small amounts. There's one guy I only know of one person who's like kind of doing it full time, like a consultant in Sweden who's like does all of his projects in Rock. But he's kind of the outlier. Like most people are sort of like, okay, maybe we'll wait for 0.1 and then maybe I can convince my coworkers to to try it out. But yeah,
Could you speak to the this design principle that you were just mentioning? The fact that you can embed Rock in other the architectural platforms and applications uh, decision. Could you speak to that? How that thing is organized?
Sure. So this gets into a concept that Rock has called platforms and applications. And so the idea here is that basically when you're writing like main in Rock, you're like, I want to make a command line app in Rock. Here's my main function. Let's put some stuff in there. Um, that main function is what's called your application. That's your application sort of entry point. Um, every Rock application, unlike every other language I've ever heard of, has to pick a quote unquote platform to build on. So the platform basically refers to like what is the domain of what we're building? Is this a command line app? Is this like a mobile app? Is this a web app? In a lot of languages, that's sort of like that's not a question. It's just like, well, you just know what kind of a thing you're building, and the language doesn't care. But Rock does actually care. So you do actually have to specify, like, I am building a command line app. I'm building a GUI app. I'm building a web app. I'm building a whatever web server. Now the platform, it's not like the language has these hard coded. Anyone in user space can make their own platform. So there exists plenty of platforms out there that you can pick from for all sorts of different use cases. But the point is that the platform basically says, okay, here are the primitives that are available for this use case. So for a web server, you might have like, okay, here's how to make requests and responses. Here's how to like talk over sockets and stuff like that. For a command line app, you might say, okay, here's how to read from standard in and write to standard out. But a web app might not have that. It might not say like, here's how to block reading from standard in. It's like, what are you doing? This is a web app. Like, don't do that. That's not a primitive here. A GUI app might have like, here's how to draw like widgets to the screen. Here's how to like paint pixels and stuff like that. And web app might be like, we don't do graphics here. What are you talking about? So all these different use cases have sort of like a foundational like set of primitives that sort of make sense for them. They also often have a certain set of needs that they need. So for example, like a web server, really basic things. It's like, what port do you want me to run on? Or do you want me to like auto pick one or something like that? Command line app, might have like, what's the exit code when you exit? Maybe a web app doesn't necessarily care about that, or maybe the web app's going to take care of that for you and doesn't need you to specify like what the process exits with. So oftentimes these sort of decisions get baked into like a framework or something like that, or maybe you want to like sort of hand control it and do it all yourself with just the lowest level primitives the OS gives you. But the point is that in Rock, kind of the idea is that someone, and it might be the same person as who's making the application, someone is going to build that platform. So all the use cases I've just been talking about, like command line apps and whatnot, you generally, as an application developer, will just pull one off the shelf. So we have a popular one called Basic CLI, which makes a basic command line interface. Right? Not trying to be a TUI, not trying to be like really fancy like UI, drawing stuff in the terminal. It's just like just like standard in, standard out. Kind of your basic scripting kind of stuff. You can put loops in there if you want. And then we have Basic Web Server, which again, pretty basic, like just request response, right? Talk to a database, whatever. But then, of course, you can make more exotic ones. So a really cool example of an exotic one that someone made is Rock WASM 4. So WASM 4 is this library that someone made for making like retro style games that run in the browser. And they have a whole like collection of them. Someone made a Rocky Bird, which is like Flappy Bird, but like very pixelated 8-bit kind of art, and it like flaps around. You can play it on your phone or on their the WASM 4 like repo of all their things. I think somebody put it on itch.io too, maybe. But basically, like anyone can make a very special purpose one of these things. You could make one for like a game engine. You could say like, here's a Rock platform for doing like Unreal 5 or whatever, anything like that. Okay. The other thing you can do is instead of making a sort of general purpose platform that's intended to be used off the shelf by lots of different applications, is you can make a bespoke platform that's just like the platform is my entire current code base of Java or whatever. And then basically the primitives that you're providing to the Rock application can be like, oh, okay, well, like in our Java code, we have this concept of like, here's how you talk to the database. I'll just expose just that as a Rock function. So now the Rock code knows how to talk to our database. Or I'll expose, here's how to like, I don't know, restart the Kubernetes, whatever. Like, whatever primitives that you want the Rock code to be able to control, you just expose these functions. And the platforms can be implemented in whatever low-level language you want. It all compiles to machine code. So basically, like anything that can sort of speak C can communicate with Rock over this boundary. And what's cool about that is that you can now have like one enthusiast at your company sets up this boundary and provides all these primitives to the Rock code. But to get your coworkers on board, they don't need to know about all that because we've made this really bright line, this really hard abstraction boundary. You can just be like, look, just write rock code. You can just call these functions in our code base just the way that they normally are. You already know what they are from like the Java versions. Don't worry about what happens in the boundary there. Um, but like over in Rockland, like everything is very nice and coherent and like self-contained, and it's just like the Rock application and the compiler just know that like okay, these primitives they're implemented somehow, but the compiler is just like yeah, cool. I'm just gonna like wire these up for you, and from your perspective, it just feels like you're using a different programming language, but it's kind of part of the same code base. So hopefully that clarifies like how the embedding story works.
I have a couple of follow-up questions, and
Sure.
they're quite technical. So, if I'm understanding this correctly, if you want to embed Rock in an existing code base, you make that existing code base expose some statically linked binaries, and then through the Rock platform, you surface out those statically linked FFIs as Rock signatures, and then you call them from Rock user
Kind of the
space
other way
of sort.
around. So what actually happens is that the rock code compiles down to a static library. So it's
Okay,
basically like a C library.
right.
Now, what makes this whole thing work is that the C library has a very unusual, at least for a C library, calling convention. So what happens is that basically it says, okay, when you call, let's say I have a rock like entry point function called I mean main is the classic one, but I'm trying to come up with something that might make more sense for an existing code base. Okay,
Select from
let's say you,
database. Select or find all users, something like that.
oh yeah, but I'm trying to think of something that would be like you've got your whole, Java, let's say web app, and you're like, I want to just use Rock for this one part. Let's say you have some sort of search thing, right?
Hmm.
And the searching has to do all this like aggregation of like columns and whatnot. And so I want to say like, okay, search. And on the Java side, what I'm going to do is I'm going to say, okay, I want to link in, like statically link this quote unquote C library, but it's actually compiled from Rock using JNI. And I'm going to say, okay, that library that I'm linking has a function called like perform search. Now, normally, what I would expect from like a C library is like, okay, perform search. Like, what's it going to give me? Or sorry, what's it going to ask for? It's going to ask for like search query string, maybe. Maybe it'll ask for like column to sort by or something like that. Maybe like limit for like number of results. Okay, so the Rock one would take those things, but also it takes a couple of extra arguments. So the extra arguments that it takes, this is sort of where the magic happens. So it basically has this little like checklist of things that need to be provided from the sort of host language, which in this case would be Java, in order for the Rock code to do its job. And those features, those things are things like, how do I allocate memory? So it's like basically you give a function pointer that's like to like malloc or something, or the Java equivalent of that. So it's like, okay, I'm running my Rock application. I need to allocate like 64 bytes. How do I do that? Like Rock code does not innately know, like the compiled Rock code doesn't know how to allocate memory. It's like, you give me a function when you call me that tells me how to allocate memory. Same thing with deallocating memory. So a cool thing about that is that that can just be hooked into the JVM. You can just be like, oh, I'll just allocate this in like the appropriate memory pool for the JVM, and like it just like does the normal garbage collection thing. You can make freebie a no op if you want, and just be like, let the garbage collector take care of it by the time the function call finishes. Then you can also specify, in addition to like how to allocate and deallocate memory, you can also specify arbitrary effects that you want the Rock program to be able to do. So this is where you would say like, okay, I need you to be able to like go query our database to like, I don't know, run an arbitrary SQL query. Cool, just pass a function like that in there. And whoever wrote the platform code for on the Rock side will say like, of course, there's the ones you always have like allocate and deallocate, but then that basically part of authoring a Rock platform is specifying what are those extra things that get to be provided in, like sort of the domain specific things, the like talk to my database that this and that, and those will just get translated into like normal Rock functions. Now, what Rock's compiler does is it presents an application author experience that hides all of that happening behind the scenes. So, as a Rock application author, you're just like, I don't know, call database, right? And you don't know that there's like, oh, a function pointer was actually passed in, and that was threaded through everything very carefully behind the scenes, so that by the time we got here, it could just call that function pointer that came from Java originally. You're just like, I don't know, call database, right? Make it happen. The cool thing about this is that what I just described means that Rock doesn't have a stateful runtime. There's no virtual machine, there's no anything. It's just like whatever your host is, if it's JVM, C, Rust, anything. It's just like all we need are some function pointers that tell us how to do these primitive operations. And those just get passed in right when you call it. And the entire static library is just like, yeah, oh, you can also make a dynamic library if you want, of course. it works the same way. It's just like, yeah, like all you have to do is just provide the primitives and the compiler just takes care of calling them at the appropriate times. So the host is in control of memory management completely. And also like exactly what primitives are available. So Rock's standard library doesn't know how to do any IO. It all has to come from the platform. So that's why they can be totally safe, and you don't have to worry about sandboxing them because it's like, well, did the platform even provide those IO operations? Okay, if not, then they're not possible. And if it does provide them, since it's just the function pointer, you can give a function pointer to a sandboxed IO operation. So, for example, this is how you can do the Dino equivalent thing. You can make a platform for like writing command line scripts that basically says, in my low level code, the function pointers I provide are like, yeah, I'll read this. I'll read this file off the file system, but I'm going to prompt the user, and you can't stop me from prompting the user because you don't have a primitive. All you have is that, right? So you can make it as secure as a web browser, all just using that very simple, concept that I just described.
Where did that idea come about? This is the first time I'm hearing about this design principle, and I find it fascinating. How did that idea arrive?
So the original idea, it really came back to that idea of like Elm, but for the long tail of domains, or like an Elm-like language. But it's funny. Rock started out as a very, very Elm-like language. It looked like Elm. It had a lot of things in common with Elm, and over the years, it's sort of developed more and more of its own character to where now, if you look at Rock code, it doesn't look like Elm code really at all. But if you look at the types, you'll be like, oh, those look like Elm types, like these, the type signatures of the functions. Aside from not being curried, which Elm is, Rock is not curried, but on purpose. but but yeah, but the reason it came from that original concept was basically I was like, what is it that I like about Elm so much? And part of it is like it's a purely functional language. It's got all these. It's a simple language. It's performance oriented. But another big part of it was just that Evan Chaplicki, who made Elm, just did this amazing job of like thinking really hard. And I was fortunate enough to have the privilege of working with him on some of these APIs and like talking with him and understanding his process and like how he thinks about things. And man, he is just absolutely just relentless about like we have to explore the possibility space of API design really, really thoroughly. We have to understand everything, like really, really do our homework on like what are all the edge cases of this API, like how what are all the different ways we could put this together, how can we make it so that it's not error prone but also still powerful enough for advanced use cases. It's really, really time consuming stuff, but once you nail it, you can make the experience of working in a particular domain much, much nicer for the person who's trying to actually get stuff done in that domain. So my conclusion was that one of the critical ingredients to Elm feeling as nice as it does is the ability to create focus within a particular domain and say like, for this domain of game dev or whatever CLIs, I've made a curated set of APIs that all work really well together. And the reason I was able to do that is because I'm able to make assumptions about what things are out of scope for this domain. Like I don't have to think about blocking on standard in for your web server because we're just not having that in the toolbox because it doesn't make sense. And so therefore I get to do, by moving certain things out of scope, I can make the rest of the experience better. So once I was doing that, I was like, okay, great. But then how do I move like Elm is compiled to JavaScript, right? It has like web APIs in the standard library. I was like, how do you make a language that where you've moved that into user space? Well, I'm like, I don't want to write the Vim script platform for Rock. I want somebody else to do that, and then I can use it and I can write an application for it. How can I decouple these and make it so that it's possible in user space to create one of these? I didn't have the term platform yet, but I was like one of these like domains, right? And create that curated, their vision for like the best API experience for this particular domain. How can I make that be like not coupled to the language and pull it out of there? And this was the design I came up with. It was basically like, actually originally I have to credit Andrew Kelly who created Zig for helping me realize what a dumb idea this was originally. But originally I thought, right, Elm compiles the JavaScript, but I want this to be for like the long tail of domains. What do I compile to? And I was like, I guess Rust, because Rust can target everything. Originally, I really had this idea. I was like, I will just compile to Rust. It'll be great. I'll write the compiler in Rust. We'll compile to Rust. Everything will make sense. And once I actually sort of like started learning more about Rust, I was like, I think this is going to be really slow and terrible. I don't think I could do this. And talking to Andrew Kelly at a conference, I met him like 2018 or something, 19 maybe. I was like, yeah, I was thinking about compiling to Rust, but then I was like, he's like, no, don't do that. What are you talking about? Like, no, just compile to like LLVM, and you can do your own machine code generation and stuff. And yeah, he reinforced that I was like, yeah, I think that was a dumb idea, which it absolutely was a dumb idea.
So some inspiration and some feedback helps. That's
Yeah.
for sure.
Well, also just contact with reality, right? Like trying to actually build that and being like, this doesn't seem like the good idea that it did when it was just in my head
Yeah, but it's
originally.
useful in the process of idea generation, and this is surely an original idea that uh, I think has big great potential. I mean, you sold me on this one. You're a very eloquent speaker, and
Thank you.
the description of this concept and this architectural design seems at least fascinating and made me at least curious about it, which um, I'm pretty sure most of this audience will probably try it as well. And I'm guessing your own community found this at least intriguing. What convinced you that this decision was a feature, not a limitation of sorts? Because once you deal with platforms that are very domain specific, you're essentially bounding the scope of the application that somebody can build to whatever the platform is able to provide. And I'm wondering if it is difficult to extend a platform if you want additional functionality, or do you embrace this limit? I mean, freedom by limitation sort of
Yeah.
philosophy.
So great question. I mean, short answer is it absolutely is a limitation, and I think it's a good limitation. Like it has like any limitation, there are downsides and upsides. I just think the upsides like seriously outweigh the downsides in this case. So one of the major upsides is security. It means that like I can have there's a whole bunch of use cases where if I don't have a reliable sandbox, I'm just not going to use this tool for it. I think a really underrated aspect of JavaScript's popularity is just the fact that it originated as the only way that you could run like securely run like code in browsers and not worry about getting a virus. So I'm old enough to remember that like in the early days of the internet, viruses were a huge thing because if you wanted to do anything interesting, what did you do? You downloaded an exe file or an executable
Yeah.
binary executable, and a lot of the time it ran and did what you wanted, and then some of the time it gave you a virus, and it was really hard to tell like which was which. So you got like Norton antivirus, like all these things to combat it. But ultimately, the thing that won was just like, what if you had a language with an actual sandbox that could do useful stuff? And this ended up being JavaScript. For a while, it looks like it might be Flash, but Flash was always like crashing all the time, and also didn't have like a super reliable sandbox. But like JavaScript actually has always had a very, very strong sandbox in the browser. Node.js is a different story, but like the one that got popular in the first place. And I think that's it's really underrated, like what you can do when you actually have like reliable security guarantees around things. Another good example is like the package ecosystem. So this is something that we all know has gotten like a lot more important over the years as time has gone by. Is like getting third-party packages off the shelf. There are still some fields like I hear game development isn't really like this. Like in game development, you have a very small number of dependencies. You maybe have like one big one, like an engine, and then like maybe a small handful of other ones. But like in normal like web development, app development, like all these other domains, it's really common to get lots of packages off the shelf. What are the odds that you're going to get something that's going to like hurt your product or hurt your end user or hurt your computer? In a lot of ecosystems, there's like really no security guarantees around like what you're getting from these packages. And because of Rock's design, you just don't have to worry about a whole like lot of categories of potential problems. And we can go into more detail on that, but like we actually have a channel in Rock where basically every time there's a new npm vulnerability, we're like, here's another one, there's another one, and each time we're always trying to answer the question like, could this have happened in Rock? Like was the exploit that they figured out, would that have been caught by just like people using Rock normally, not having to like do fancy extra checks, just like would this jump out at you and like it just like wouldn't even work? And so far, it's like I think it's been all of them have just been like, yeah, this would never reproduce in Rock,
This is
just
fascinating.
because of the yeah.
So, if I'm understanding this properly, most of the responsibility for this sort of sandboxing and security and the reliability of runtimes probably moves to the platforms, right? Um,
Definitely.
how do you plan on guaranteeing that? I mean, who's going to write the platforms? Are you going to have a platform marketplace and let them filter themselves out by reputation?
Yeah.
How's that going to play out?
I mean, that's the short answer is yeah. Like, so basically, the way I like to think about it is, um, so let's say that I am running JavaScript in my browser. Well, how do you guarantee that the browser is secure? It's like, well, trust and reputation, right? There's like a small number of browsers and you generally trust them. Most people are not like trying out like random browsers off the street. I mean, you certainly can. There are a small number of, independently developed browsers out there. Shout out to Ladybird, for example. But like honestly, I would be fine with. I actually tried building Ladybird unsuccessfully. They don't have like a distribution yet, but like I trust the people who are involved in that project enough to be like, okay, this is not a virus, right? This is not going to give me something
Hmm.
malicious. But at the end of the day, I mean, I couldn't come up with a way around that reality of just like, at some point you just have to have some amount of trust somewhere. And I think there's a really big difference between saying like, I need to trust one thing in this entire chain versus I have to trust every single package I depend on and every single package they depend on, and every single package they depend on. All this like fractal all the way out. And like and of course, the most commonly compromised ones, like how do they do it? It's like they get some popular package that's like used by lots of people. It's got some like tertiary dependency on this other thing that's like not visible to the people maintaining the popular thing, and they go attack that. That's the thing that doesn't really work in Rock. I mean, you can try to do that, but like good luck. I guess is what I'm saying. I'm not saying it's impossible, but it's just a lot harder. First of all, you need to do something with I/O because another one of Rock's features is that you can tell at a syntax level whether a function is pure or not. So
Yeah.
pure functions, effectful functions, we call them pure functions and effectful functions. Effectful functions end in an exclamation point. That is tracked in the type system and enforced. Well, you don't have to put the exclamation point, but the compiler will warn you if you don't. But they like the functions literally have a different type. It's a thick arrow for the return value versus thin arrow. Thin arrow meaning pure function, thick arrow meaning can do effects. And so like for example, if your library is trying to be like, oh, I'm going to go ahead and just like sneakily do some like cryptocurrency stuff. I'm going to go like mine some Bitcoin and like send it off somewhere, or I'm going to try to like go searching around for wallets and stuff like that. Well, the way that the package ecosystem is designed is, without going on a huge tangent, is such that basically if I want to make a package that does IO at all, in order to make that platform agnostic so it can run on multiple platforms, I basically need to say like, well, when you set up my thing, like I always give the example of like a error reporting service like Bugsnag or something like that or Sentry. When I sort of initialize that and I give it like my API key and say like, okay, here's my API key, whenever I call this thing, use that API key. I don't just give the API key. I also have to give it, here's how to do a network request. Cause like, you don't know how to do that, library.
Yep.
And of course I can sandbox all those myself if I want. So I can say like, in the same way that the platform boundary works, I can be like, here's how to do a network request. And by the way, if you ask me for a URL that's not api.bugsnag.com, I'm just going to 500 it and not actually send it because what are you doing? That sounds really suspicious. That's like one extra line of code. And now I've just sandboxed that entire dependency. And it's like, I've just given, it access to do the very minimal set of IO that I think is reasonable for what that dependency wants to do. And it literally can't do any other IO because it doesn't have access. Like only your application can depend on a platform. You can't like random packages can't just be like, I want to use that platform. That's not even a thing. Like syntactically, that doesn't make sense. So all of your dependencies are only able to access what you as the application author give them access to. So executing an attack like that becomes unbelievably difficult. I mean, you have to basically like the stars have to align where it's like, well, it was already something that was doing IO of the exact type of IO that I wanted to intercept, and also I can use the URL in a way that no one's going to accident, do even the most trivial sandboxing around, or like I don't know. It just seems like a lot of these attacks that we're seeing in the wild of people, especially going after like financial stuff, just get really really hard to execute if you have this like sort of security model baked in.
Fascinating. Uh, I mean, you sold me on safety too.
Cool.
So I wanted to pick up on one thing that you said, and I noticed this in the Rock tutorial as well, which is this difference between pure and impure functions, um, which is tied to this notion of effects and side effects and the pure functional programming concepts. But I
Mhm.
also saw I'm gonna use that as a jumping off point to a question that I had about Rock's design, which is the fact that you seem to embrace some FP concepts and deliberately avoid others. For example, um, as I was going through the example sections and as I was going to the advanced section of the doc site, I saw a section on abilities, and I was reading. Okay, abilities. This is a new concept. I was reading this, And then I saw the table of contents and I saw the EQ ability, the hash ability, and I was like the DiCaprio in that meme. And I was like, type classes. So there's I noticed the intentional phrasing to avoid FP fanciness. What are some concepts that you deliberately avoid from the FP world, and what are some concepts that you deliberately embrace in Rock?
Yeah, great question. Yeah, I should note, abilities are something that's actually gotten replaced by something that's even more powerful, but also more mainstream at the same time, which is called static dispatch, which we can kind of go down. But that's like one of the reasons that we rewrote with the compiler was that we made a number of like big design changes. So we have not shifted over the website yet because the new compiler is not like fully usable yet. So we don't want to be like,
Okay.
here's a tutorial. Go try it out, but don't try it out because it's gonna break, right? So we're kind of in this like weird transitional stage right now. We actually were just talking about like maybe we've gotten the new compiler to the point where maybe we should put up a warning because like some people did do advent of code in the new compiler, so it's like it's not that it doesn't work at all. It's just it's not nobody's making their day job on the new compiler. That would not be smart right now. um, but anyway, setting that aside, you're asking about like FP concepts and like which ones I like intentionally avoid versus like intentionally embrace. So pure functions, actually rewinding time a little bit, I actually remember when I was getting into Elm, we were kind of experimenting with like, I don't know, is there like, could we use a better term than pure functions? 'Cause it kind of sounds kind of like high and mighty, right? It's
Yeah.
kind of like, oh, my functions are pure and yours are dirty, right? So we weren't sure like what, like what would be the best way to do that. And so we actually, if you look at some of my early Elm talks on like YouTube or whatever, you can see me kind of like trying to workshop. I was like, I like to call them stateless functions. It didn't really stick. Actually, I think mostly because of the JavaScript community, being like because it's like so extremely mainstream. And I think specifically React maybe was like what kind of started this out because they were talking about how render should be a pure function, and it just kind of the term like went mainstream and like didn't somehow have like negative connotations. Despite like I don't know, like one of the things we actually talked about a lot on Rock Zulip was like what should we call the thing that's not pure function? We ended up with an effectful function, but it was important to me that it's not judgmental. It's like no, they're not like bad functions. They just like do side effects. And it's not that side effects are like evil. Sometimes like the effect is the whole point. It's like you want to do the IO. It's like what else do you call it? So that's where we ended up with effectful, where it's like non-judgmental, but not pure. Anyway, so I mean, to directly answer your question, the biggest one that I try to avoid is monads, because I think
Yes.
it's like I have a little like entry in the FAQ about this where like about like higher kind of polymorphism and why we don't have it and like there's this classic thing that happens is like you have like two people who don't really know each other and they start talking about programming and one person says like oh it's like a monad and the other person's like oh no monads okay here we go and now it's going to be a whole thing like this is not like I understand why like I understand the whole thing. I understand like different people's point of views on this. Like if you're writing Haskell specifically, you can't avoid it because it's in the standard library. You have like this function takes a monad. You're like, how do I know what I can pass to this function? I have to go learn what a monad is. I understand why if you're a Haskell programmer that's necessary. I also understand that like Phil Wadler originally came up with this very elegant solution to how do you do purely functional I/O, and he did it based on monads. I like others would argue that somebody else would have come up with the same solution. They just maybe wouldn't have called it monads if you gave people enough time. But Wadler was the first one who came up with it. He wrote a paper about it. He called it monads. The terminology stuck in Haskell, and then you have the whole. And this is the part that I guess is maybe more contrarian, and maybe I'm going to lose some of your audience here, but I'm going to say it anyway, which is that I don't think that like knowing and understanding what monads are is like broadly critical for like all of software development. I don't think like, I don't go up to a Go programmer. I'm like, your life's going to be so much better if I teach you what monads are. Like, there's just not, it's not like if it's very useful as a term for talking about a certain category of purely functional API design. And honestly, I think applicative is the more useful of the two. Like if you can say, this parser is monadic versus this parser is applicative, like only needs applicative versus actually needs full monad support. That can tell you things like for CLI arg parsers, can I traverse it without actually having to execute it? Because if it doesn't support the monadic operations and it's just applicative, then you can do the cool thing where you're like, I specify the parser and also the like help text for all of them at the same time. And because it doesn't need to be traversable, like the entire thing doesn't need to be traversable and executed, I can go generate the help text statically. That's very useful. And if I know the term monad and I'm talking to the term someone who knows the term monad, I can just explain it in terms of monad and applicable. They can be like, oh yeah, that's cool. Um, but for somebody else, I wouldn't just use those terms at all. I would just explain, I would just cut straight to the punchline, just be like, it's a cool parser because the way it's designed is so that you can define the, what we're parsing and then also the help text for it. And we can just generate a whole, help text, dash dash help for you. That's the selling point. That's the thing that people care about. And you really kind of need to get into the API design weeds before like those distinctions matter. And even then, it's like you don't need to use like explain that it's a monad versus an applicative. You can just explain like, well, look, if you support this operation where it like returns a new one that's got the wrapper around it, then you can't. And when you traverse and you're trying to generate the help text, you get stuck there because you have to actually execute it before you can get to the next one. Um, I'm just more of a like, let's just cut to the chase. I think the experiment has been done like really thoroughly of like, is this a term that a lot of people pick up quickly and get a lot of value from? It's like, no, nothing could be further from the truth. Like it's something that people struggle with a lot and then also struggle to get value out of after they've learned it, unless they're in a language that like requires it, like Haskell, requires knowing it.
Right.
So I'm sorry if I've offended some people's sensibilities as a functional programmer with that. But like, I think that's something where we've done the experiment, and my conclusion from the experiment is it's just better if we just like the concepts are there, they're under the hood, and it can just be an advanced thing that you just is not a requirement for using the language. And we don't need to culturally like obsess about it. We can just be like, yeah, it's a thing, it's a term, but like you don't need to know it to use this language. And if you want to get into those API design weeds, then sure, you have at it.
This is a okay. I'm going to use this to use your argument as a segue into a pattern that I've noticed while you were answering my questions. I wanted to get into teaching because you wrote a book. You wrote an excellent documentation for Rock. It's just so succinct and very comprehensive, and just gets the point across very quickly. You're an
Thank you.
eloquent speaker, and a good part of teaching. I noticed this in my own career doing courses and stuff, is that in order to be an effective teacher, you have to empathize with the audience. And this is a pattern that I've noticed you doing while answering my questions. So I saw you on a number of occasions thinking about the audience of Rock, how to make the language easy and accessible for them, even for this monad argument. The Your thought apparently was towards making life as easy as possible for the users. Um, the um, um, the security of Rock, just to make things easy as possible for the software developer, and this empathy pattern was obvious to me as you were speaking about the various topics that we were discussing. So I was wondering, how did that come about? So this empathetic approach to software development and towards, I don't know, good, reliable software, and also in teaching. You can take this anywhere you want. This is a long-winded question and a pretty broad one, but I was one, and it might lead nowhere. By the way, if you want, we can jump off to something else. But I was really curious about your approach to building things in this way.
Yeah, there's two parts to your question. So one is like how do I think about like empathy and stuff like that, and the other is like specific to teaching. When it comes to empathy and things like that, that's honestly like kind of the core thing that motivates me to build software in the first place is just like I want other people to have a good experience using software. And you asked me about goals earlier, and I said like I want lots of people to use Rock to make good
Yep.
software. Um, and implicit in that statement is like, well, if they're using it, I hope they're having a good time using it, obviously. Um, but like, to make good software that other people will like. So one of the things that I like about language design or like making languages is that if you can successfully make a language that other people use to make other pieces of software, then it's like I've managed to expand the reach of like how much happiness and like joy I'm able to like create in the world. Um, Something I realized about myself when I was like a lot younger, is just like something that really drives me is the idea of making other people happy through something that I've created, and especially if it's something that I created that they can use without needing me to be there. So it's
Mm.
like an artifact. It's like I make this thing and then I hand it off to the world, and then hopefully, if I've succeeded, they are happy because they used it, or like they got value out of it or whatever. And that, now that could be a piece of software, but it also could be like, I have like a podcast, software unscripted, I give a lot of conference talks, like things where people come up to me, they're like, hey, I used, or I watched, or I listened to whatever this thing that you create. I read this book, Element Action, whatever, and I liked it, and I it made me happy. I got my life is better because of that. I really like doing those things, and so it's not like empathy as a tactic here. It's almost like that's the payoff for me. It's like I'm trying to think about, like, when I'm teaching somebody, part of this is like, I know people are going to watch this, right? So I'm just constantly thinking about, like, how do I make a good experience for the person who's listening to the explanation that I'm giving? That's just kind of my mindset. And even if I'm not there in the room to clarify, right? And the tutorial is the same thing, where it's like, if I want the person to have a good experience reading the tutorial when I can't be there to like answer their follow-up questions, how do I do that? And it just has to be like, well, the only way I can do that is by, thinking about like what's going through their mind, and what are they potentially getting stuck on, and things like that.
This is a very nice motivator and a very underrated one. I do resonate with this because I sometimes get this sort of impression from people when I meet them in conferences and they shake my hand and tell me very similar things about, I don't know, one of my courses or an article that I wrote or something like that. So I very much resonate with that. About the teaching side of things, was that a skill that you intentionally developed, or did that just arise naturally from this sort of core principle that you were just discussing?
I think it's a mix of things. So, I definitely had some strong opinions just based on some negative experiences I had getting into functional programming and trying to learn it around the way that it was taught. Um, I think specifically, if there's one thing I could, go back 15 years and scream from the rooftops to like everybody who's teaching FP, it's like, don't teach types first. Everybody does it. I understand why, because once you get into it, that's what you're thinking about. Is like you're always thinking in types first. The problem is people who are coming in. I'm not going to say everyone, but I think a whole lot of people who are coming in are just like, I want to build something. I want to make the computer do a thing. That's why I like programming. I like to make the computer do a thing. And you're talking to me about the shapes of the data, and like I don't care as much as I care about. I want to make a hello world, and then I want to make it interactive. Like that's what I want to do. Start with that. Get there as fast as you can. Like IO should not be in chapter 7, even if it's you have the IO monad. Just don't say monad yet. Just say there's this IO thing. Don't worry about it for now. We'll get back to it in chapter 7. Moving on. Here's how you build stuff, right? Um, and because I was frustrated by that, I had a friend who very persuasively convinced me that I would like functional programming if I tried it and like gave it a shot. But it was so frustrating reading all these tutorials and like introductions to FP, and I'm like, but the thing is, I want to build stuff. Like, when can I, like, and like slogging through all this and not having any like anywhere to hang my hat, and I'm like, okay, I'm really taking your word for it increasingly that all of this is going to lead up to a good building experience. But yeah, I think so I had some, I was like, I don't want to do it like that. So I'd already had some thoughts about like, how do I want to do it instead? Combined with the fact that just like in the early days of Elm, there just wasn't a lot of teaching material yet. Like I was a very early adopter. And so because of that, I was like, oh, well, this course doesn't exist. Like front end masters approached me and they're like, we want to do an Elm course, and we heard you're a good person to talk to. Manning approached me about an Elm book. They were like, we don't have an Elm book, like, and one thing led to another. And so in the case of each of those, I just sort of ended up finding myself teaching people, and sort of practicing like different techniques and trying things out and learning what worked and what didn't. Just because I was like, I have some thoughts about how I want to do things or try to do things differently than how I learned it, combined with the fact that there was just like demand for teaching this new language.
I'm going to ask a couple of self-interested follow-up questions as a teacher. What kind of mental tools or techniques did you find while teaching that were, I don't know, that worked for you really well? That, I don't know, maybe came as contrary to the general consensus of how workshops should be done, or how teaching should be done, or how books should be written, and things like that. Are there any mental tools or techniques that you've used with great effectiveness that are not as widely discussed?
I don't know how widely discussed it is or isn't, but I will say there is no substitute in my experience for the experience that you get from physically walking around and looking over people's shoulder as they try to like write code and stumble through it when they don't know you're watching. Like they know you're in the room somewhere, but they're kind of absorbed in what they're doing. And like a really simple example of this is that there was this thing that I thought I had this whole roller coaster of like, oh no, this is a big problem to like, oh no, maybe it's fine actually. And then to being like, okay, now I understand this better, which was around, this is a real little syntax quirk of like ML family languages like Elm, is that the way that you do parentheses is just a little bit different than the way that you do them in typical mainstream languages for nested function calls. So because they do like white space based calling rather than like parens and commas. So if I wanted to call a function called foo with arguments a and b, I would just say foo space a space b in Elm. That's like the normal way to do it. Okay, but now let's say that instead of b, I want to like call another function. I want to call bar. So I would say foo space a space open paren bar space blah 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 close paren. So it's sort of like math where you just have, parentheses are just like everything in here is just like exactly the same as if it were outside the parentheses, except I'm using the parentheses to nest something. Um, but because everybody has this sort of like habit from mainstream languages that they're usually coming to this workshop from, of doing foo immediate open paren, no space, and then like commas between the things. I would see a lot of beginners mess that up. Like we'd get to our first exercise, I would even call it out in the workshop. I'd be like, now this is a really common thing. Don't feel bad. Everybody does this, but here's how you do it, nested function calls, blah. And I'd make sure to put in one of the early examples that like you needed to do a nested function call so that people could like build a habit. No amount of emphasizing this prevented me from walking around and seeing people make the mistake anyway. Not everybody would, but like always there would be like multiple people. So I'd watch it and I was like, man, like what could I have done differently to I emphasized it. I even said like, this is a thing you're going to run into. I made an example that really clearly exercises this. And what I watched would happen is that they would make the mistake and then they would see the compiler error. And the compiler error, fortunately, Elm has really nice compiler error messages, which is something that we trying to preserve and rock because it's really important. And the error would explain what the problem was so well that they would be like, oh, okay. And they'd go and fix it. And then they'd move on. And then like, I'd be like, oh, so like, this is not like, I don't need to like restructure the workshop around this. I don't need to like go back to Evan and be like, man, you should really consider changing the syntax of this language. It's like, no, this is just like one of the beginner things that people trip over. And it's okay. Now in contrast, like currying and especially JSON decoding of all things were the two things that I saw people get stuck on in a way where they didn't self-recover. Like they didn't like, and again, like plenty of people did get currying, but then like also plenty of people didn't get currying. And I could tell that by the end of the workshop, there was a lot of the class that was sort of like, I still don't understand it. You explained it multiple different ways. You answered my questions about it, but I'm just going to take your word for it, man. I'll, maybe someday I'll get it, but like, whatever. I'm just going to use it. I'm going to keep building stuff and, thanks for unblocking me. And, I take your word for it that this makes sense with the arrows and whatnot somehow. Um, but yeah, so I guess the reason I say like, no substitute for like walking around and like seeing what things people are actually stumbling with is like, there are some problems that people can self-correct on, especially if you've like given a little bit of material and like have some comments in the examples that can like guide them a little bit. But then there are other things that it's like, even if you like really, really try to hammer it home that people just like don't get. And at that point, I think you have to start thinking about as a teacher, like, do I do an intentional hand wave and just say like, look, this concept is like more advanced and like I'm going to explain it to you on a basic level. There's more to it than this, but we're not going to, for beginner material, go that deep into the rabbit hole. If you want to go into the rabbit hole yourself, here's some further reading, but like we're just going to give you the basics and move on. And yeah, I think the best way to find out those things is just by like actually watching people try to apply the stuff you just taught them.
How about writing? So you gave an example of a live workshop, and that probably holds for, I guess, any sort of spoken or demonstrated material in real life, like even a conference talk, maybe. How about writing? Is there a teaching technique that you, or a teaching principle that you use while writing technical documentation, or a book in the case of Elm in Action, that you saw your fellow doc writers or book authors do not?
Well, there's something I tried to do with Element Action, which I don't think I would ever do again because it turned out to be way more work than I anticipated, and I don't think the payoff was worth it. So in Element Action, the entire book is built around one code base that you build from scratch, and every chapter you add more and more features to it. The reason I did this was that I wanted people to experience that, in my view, like one of the best parts about Elm is when you're working on a code base that's like mature and you already like know, but like you're trying to make serious changes to it and add features and stuff like that. The amount of help you get from the compiler is like awesome. But of course, if you're only ever building small self-contained examples, you never see that because you're not working on a big code base. So I was like, well, let's just build up a big code base and I can just organize each chapter so that it builds on the previous one and then blah, blah, blah. Here's the problem with that. Let's say I'm working on chapter 7 and I realize, damn it, I needed to teach things in that one thing's in chapter 3 and another one's in chapter 5, and I actually need to swap those around because if I don't do that, like the way I have it right now, by the time you get to chapter 7, you haven't learned this thing that you need to learn in order to teach this thing the way that I need to teach it. All right, that's okay. Let me just go back to chapter 3 and change it. Well, the problem is now I go back to chapter 3 and change it. I have to propagate that change manually through every chapter in between. So when I was starting the book, I didn't have this problem yet. I didn't realize what a pain this was going to be. But then as I got further and further into the chapters, I realized that every change that I made that impacted a previous thing was no longer local to that other chapter. I also had to go through and update every single code example throughout all the other chapters. So I wouldn't recommend doing that. It was way more work than I think the payoff was worth. Just to give people that experience, especially because as I learned, like most people don't read the whole book cover to cover anyway, so like they probably weren't getting that experience anyway. Um, anyway, so you're asking about like what advice would I give to somebody who is writing a book or technical documentation or something like that that's maybe outside the mainstream. Uh, I think the main thing that comes to my mind is a principle that my editor at Manning articulated, I think, very well. Alicia Hyde, shout out to Alicia, which was basically, and I think this is maybe just a general Manning principle, which is sort of wait until the last possible minute to teach the thing that you need to teach. So motivate it by being like, we're going to build blah, and I'm just going to teach you only the bare minimum things that you need to build blah, and I'm going to teach them to you at the last possible minute that we could need them to build blah. The cool thing about this is that it makes it so that it's a really strong forcing function for preventing yourself from bloating the explanation and sort of putting more in the reader's head than they need, which is a big problem if you're trying to teach them new concepts. The minimum number of concepts that you can teach that can like sort of fit in the reader's head just helps them out. It means that they don't, they're more likely to be able to actually absorb what you're doing. It's sort of cutting scope and minimalizing it. And if your goal is to end up with like readers who are not confused because they're off going on tangents and whatnot, this is I think the best strategy I've heard of to get there. And yet I've only ever heard Manning articulate that. I've never heard anyone actually say like wait until the last possible minute to teach whatever concept is necessary in order to let the reader build whatever they're about to build.
I'm gonna steal this idea when I'm creating new courses or new learning material. Though a similar thing that I had in mind, or that I keep in my head while designing new learning material and new courses, is that sequencing matters, and it's okay at the
Oh
at the
yeah.
beginning to start with a slightly like technically incorrect model as long as it gets you productive and it gets you a starting point. It's like the turning of a key when you're starting the car, right?
Right.
You turn the key and then you start the engine, um, and that goes hand in hand with the idea that you were speaking about, which is that you should wait until the last moment to teach something that might be complicated and that would otherwise put a great burden on the, I don't know, reader, student, watcher's mind early, which yeah can cause frustrations and overloads them with unnecessary information. So thank you for that. I'm going to take this away and
Sure.
for for the upcoming learning material that I produce, which might be pretty soon. I'm gonna produce some tutorials. I wanted to ask about this teaching thing that you've been doing for quite a while. What does that given you so far in terms of, I don't know, personal satisfaction or career satisfaction or, I don't know, opportunities? How has teaching helped you in your career?
Well, I guess I could say a few different things. So one is okay, so the book Element Action definitely on a personal level just feels really cool. Like I got these physical books that I made, like, I wrote the whole thing. That just feels great. I don't know, there's something tangible about that, and also just the fact that it's a major publisher. Um when I was setting out to write it, I I talked to a number of people who have written books for either major publishers or like self-published or things like that, and so I've got some different perspectives. One common thing that everybody told me is like, don't do it if you're expecting a lot of money, because this is not, you know,
A
you're
lucrative
not going to
thing.
write a New York Times bestseller programming book, all right? It's not going to be a lot of cash, and they were right, but I knew that going in, so that was fine. Actually, one of the people I talked to was Runar Bjarnason,
Hmm.
who wrote the Scala Red book. We used to be coworkers, and so I got his perspective on Manning specifically. Um, but yeah, so basically, I think that aspect of it is maybe not so much about the teaching, but rather about like that particular artifact. I really wanted to like write a book for a major publisher that was in the In Action series for a purely functional language. This is the only one that exists as far as I know. So uh, there's like Elixir in Action, but Elixir is not a purely functional language. There's like Haskell. I think there's like, what is it, Haskell in Theory or Haskell? I don't know. Manning has like different series of books, and the In Action one is supposed to be for like in action, meaning like using this in production, for your job, like doing practical stuff with it. And I really wanted there to exist in the world like major publisher, purely functional language, practical, right? Just like focus on practicality, to sort of like try to help pure FP like break out of this reputation of being like it's only for academic ivory tower stuff. So I was really happy about that. That was like a selling point to me of like doing the project in the first place. I don't know if that counts as being part of the teaching thing, but I mean it's in the category of teaching, so that was a personal satisfaction thing for me for sure. Um, I also just like doing it in general. Like I like teaching a room full of people stuff. It's like pretty tiring by the end of it. But I always, walk away from it feeling like that was fun. Like that was cool. Got some good questions in there, and I like to see like people excited as they like have some like light bulb moments, like understand things. Um, and I mean, I guess like on a financial level, at least for front end masters, like front end masters, I don't know what other like platforms pay, but like they pay well, and like it's not like a life changing amount of money, but it's definitely like a number of guitars I own changing amount of money. So it's definitely it's nice to like see the royalty checks come in like on a regular basis. I make way more from front end masters than I do from the book for sure. So um, that's like a it's not like I'm like not like a super money driven person. I'm not like I've not organized my life in a way to like maximize my financial returns, but it is pretty cool to just see like, oh, this is actually so valuable to people that they're willing to pay me for it. So there's something nice about that feedback loop where it's not just like, oh, I'm just doing this for free and like I don't know, I guess like maybe people like it, maybe they don't. It's like no, people are like on a recurring basis paying money to like get this knowledge. So I must be doing something right in terms of teaching, for people to keep coming back. So that like on an emotional level feels good as well as yeah. I mean, guitars are nice.
I can attest to that. I have a couple of
I,
in the back of
I see him
this.
back there. Yeah.
Um, what do you maximize by in terms of career strategic decisions? So I get it. You're not a money maximalist, and I I can empathize with that. What are some what are some strategic decisions that you've made in your career that have paid off really well for you in terms of whatever you define as your career capital of sorts?
Huh. Um. Well, I don't know if they've been terribly strategic, if I'm being honest. I'm not a big career strategy guy. I've mostly I've mostly just kind of been like I want to work on projects that I find interesting, and like work with people that I like working with, and that's about it. Uh,
These are as
so
strategic as strategic decisions as one can get. I had a follow up comment to this one, which is that pretty much the most creative and ingenious people that I know have essentially based their their decision on a very few set of principles, like just work with nice people and go on do projects that you think are fun. So yeah.
Yeah. I mean that's pretty much it. uh I will say I think I've gotten better at if you want to get into like career nuts and bolts stuff, I think I've gotten better at evaluating other companies. So I've tended to work at startups. I kind of find that I like that smaller, less bureaucratic kind of environment, generally speaking. So I've tried to gravitate towards them. And since I figured that out in my career, uh, and I will say like as I've been interviewing startups, especially like really early stage. So if you're somebody who wants to go work at like a 5-person startup, when they're like that early on, it is pretty important to try to evaluate like does this company like have a shot at like making it, and also like do I want to be a part of that, because especially in when the company's that small, you're going to be working more hours and harder, and there's
Right.
there's going to be less of a bright line between your job and your personal life. The pager goes off, that type of stuff, and you have nobody to pass the buck to. um might be some crunch time and stuff like that. uh and so you do want to kind of evaluate like, do I think this company's going to make it or not? And some of the companies that I interviewed with early on, like back when I was not, well, before remote work was a thing, and it was sort of like, well, who's near me? And I wasn't living in like, California or anything. I was like, all right, well, I guess it's whoever's hiring. That's my, potential pool of startups to work for. Hiring and driving distance. That's it. And whereas now you have a lot more options, obviously. And so I think it is try to sort of more important than ever, if you're in that situation, to try to have like, when I'm interviewing with you, I'm also interviewing you as like someone in the company. So if they give you the option to ask, hey, what questions do you have for me as the interviewer? I think it's good to have prepared like questions about that, and especially the further you get in the process, to have more and more hard-hitting questions about like, okay, like what's the plan for the business model here? Is there a plan for the business model here? Like, and does it sound like a plausible business plan, or is this sort of like, oh, this is kind of like investor fairy tales? That's just going to keep going back to the well until the investors say no, and then we go out of business. Because there are companies like that. So, yeah, that's the best advice I would get is like try to learn about the company, and try to actually forecast like, does it seem like this company actually has a future? Because a lot of them don't.
Do you have any tips on how to do that? Signs that you look for, red flags that you watch out for?
Yes. So the one of the biggest bullets I successfully dodged, I'm not going to say who I was interviewing with, or what the company's name was or anything like that, because they're out of business now, but still, was basically like, their interview process for interviewing me was, I thought, very weak. It was like they were like asking a mix of like questions that were like way too softball, and like this, I'm like, this is like really easy to answer, and stuff where I'm like, this is not my job description, like that I'm like applying for. So like, you're not doing a good job evaluating me. Like if you give me an offer, I look around at like the other people at this company, I'm like, is this how they were all evaluated? Like just kind of scattershot, like random chance. Like you asked them really easy questions with regards to their job description, and then like really like silly hard questions that like had nothing to do with what their job is. Um, because I mean, maybe you can luck out and put a good team together that way, but it's just luck. So I'm like, do I want to roll the dice on like this being the coworkers that I'm, signing up with? Plus it's just, I mean, general stuff like, if people are jerks to you in the interview process, that's they're probably going to be a jerk to you on the job. Um, I realize not everybody is, motivated by the same things that I am. Like some people are like, I knew somebody who was like, I really want to work at company X. Like that's the most important thing. I really want to go to that company. They like studied and read all the like, do all the leak code grinding or whatever. I've never done any of that. I've just like, I'm like, look, if I show up and they interview me and they're like, your skill set doesn't match what we're looking for, then I'm like, okay. I mean, either your process is bad and my skill set did match it, in which case I guess I dodged a bullet because your interview process is bad and you're not hiring people very well based on that. Or maybe my skill set didn't match your stuff and it wasn't going to work out anyway. Either way, like I I think if I am feeling motivated to study for someone's interview process, that's a red flag to me. But obviously, that rules out like all the like giant tech companies, because as I understand it, it's like kind of the norm to study for those interview processes. So, don't take my advice on that if that's the type of company you want to work for.
Do you have any sort of books or resources for learning, in the sense that, so I wanted to ask the general the more general advice to younger self question, but I wanted to skip that, and rather I would focus on fundamentals. And as I want to also ask some questions about AI because you're working on Z and you're building an AI embedded tool. Um, I wanted to ask about the role of fundamentals and where you would advise, let's say, newcomers to thoroughly study fundamentals, especially in the age of AI, so that you're well prepared to do software engineering really well. So, if you have any sort of tips on how to master fundamentals really well.
I wish I did. The problem that I have with giving advice on that topic is that the way that I learned is, I mean, if I'm being honest, it was kind of school of hard knocks. Just like, I started writing code at a young age, and I made a lot of mistakes, and I learned from those mistakes. Then I got on the job, and I made even more mistakes, and I learned from those mistakes. And eventually, I kind of, by seeing lots of things that didn't work well, and then like hearing lots of people's theories about what they said, would or would not work better. Um, and some of them I was like, well, I tried that and it didn't work, so I guess not. um, so I wish I could have some text I could point to and be like, oh, just go read this, and then you know how to do software architecture well or something like that. But unfortunately, I don't. The closest book I can remember reading about reading and thinking like, yeah, this mostly makes sense to me was Osterhout's I think it's called A Philosophy of Software Design. Um, and I remember like that book was kind of cool because he did a lot of surveys of like I think it was college students, or maybe people in industry. But it wasn't just his opinions. It was like he went out and talked to a lot of people, and he was like, "These are the common threads that a lot of people reported," and I generally agreed with a lot of that. I would also say like when it comes to I don't know what the right term for this is, but sort of like leveling up and cutting through noise. I think Casey Muratori has really, really good teaching materials. His course, Performance Aware Programming, is really, really good. And when I think about fundamentals, I think everybody has a different idea of what that term means. I will say, I have an anti recommendation, which is literally, and I'm using the word literally, not in the colloquial figurative sense, but like literally every single piece of advice that you ever read that is about how to do proper object oriented design, ignore it. If it says here's how to do well, just don't pay any attention to it. I'm not saying it's necessarily wrong. I'm saying that there is almost like there is such a very strong correlation between what is considered good practice by standards and what I think is actually a terrible idea, that if someone is claiming this is good design, I'm not saying do the opposite of that. I'm just saying just put it directly in the trash and just do not pay any attention to it, because if it is good advice, it's by coincidence, and you're better off trying to search elsewhere for good advice. So that branding, I think, of like this is good practice is to me a giant red flag now. It's one of the few areas where I've just been like, okay, the evidence for this being bad has piled up so high in my mind and my experience that at this point I'm just like, anything that says like this is good design, I'm like, then I'm ignoring it. It's straight in the trash.
That's so
So
interesting.
I mean, I say this despite being a fan of a number of people who give such advice, and like I said, by coincidence, sometimes it is also good advice, but I wouldn't trust any of it, despite liking some of those people. So, uh, but anyway, but yeah, I think Ousterhout's book, like again, I wouldn't agree with all of it. I do think Casey Muratori has some good points about API design. I think API design is really, really important. If there's one thing that I think is a fundamental that cuts across every aspect of like every language, every like no matter what you're doing, is like figuring out which boundaries go where is like the a really, really hard thing to do well, but it's really, really important and makes a huge difference in like how many headaches you're going to have, how many security problems, how many performance problems, all of these things. Like it just touches everything. Um, I don't think there's a quick way to get good at it. I think that is something that does require a good amount of like school of hard knocks of just like you make mistakes and whatnot. But I think being aware of it and noticing that like where to draw boundaries around things and like who has access to what and under what circumstances you allow certain information and certain capabilities to pass through, um, is a really big deal. So paying very close attention to that, I think, is important. Um, if there's one thing that Casey, I think, would disagree with in Ousterhout's book, there might be multiple things, but I think he would probably disagree with uh, the sort of claim of like make things private by default, and then like only expose like the minimal set of things. Casey gave it, I don't remember if it was a talk or like an interview at some point, but basically he made the case that that is sort of like lazy. And the idea of like make everything private and just expose the minimal set of public things is wrong, because what you actually need to do is something that's much harder than that, which is you need to think very, very carefully about, no, like actually here are the things that I need to give you the ability to do. And in some cases, just like that means just making them fully public. And basically, like you might get it wrong, but you have to do it anyway. You can't just be conservative and say, like, well, we'll just like hide everything and then like just give you access to this and that. It's like if you have any kind of a default policy, you're already being too lazy. Like you need to just have thought about like this needs to be exposed and this needs to not be exposed, and every single thing needs to have thought through like which of those two categories it goes in, and anticipating future needs and balancing that against blah blah blah, and you know, giving people the ability to get themselves unstuck while also creating whatever guarantees are necessary to keep the system sane and able to evolve. And yeah, it's a daunting task to get good at that. And I know very few programmers who I would say are like absolute masters of that. And of the ones I've worked with, Evan Chaplicki is the one who I'm like, yeah, he's an absolute master at figuring that stuff out.
And the
Um,
School of Hard Knocks definitely helps because there's no one recipe that gets you good API design. I mean,
yeah.
this is why you have such piles of advice, right? For various pieces of design. And most of that just are not. Maybe they are good recipes for specific use cases, but anyone who tries to sell any sort of single advice or any single pattern as the pattern with a capital P, is probably doomed to fail because there's just not one single principle. You just have to write a lot of code. You just need to have written or have gotten enough experience writing different styles of software, different scales of software, to be able to get some taste for what
Yeah.
good.
And it's like that's necessary but not sufficient, because honestly, I think like for most of my career, I'd spent a lot of time writing code, but I don't think I was very good at it until I started like thinking more about it and like being exposed to other like alternative designs that had a different set of trade-offs than what I was ever thinking about or even necessarily using before. Um, Definitely it's easy to emphasize the wrong things. Like when I was spending a lot of time in the JavaScript world, there are a lot of things that I spent a lot of time thinking about, and like the whatever APIs I was designing for libraries or things like that, which now I look back and I'm like, those were all totally irrelevant. Like I had all this all this time obsessing about the wrong things. And I think those are like cultural norms. So it's not even just like it was just me doing that. It was like there's a lot of people, and in fact, a lot of them have gigantic YouTube channels and stuff like that. And I'm like, I look at what they're doing, I'm like, this is not making the big, like you're making a huge deal about something that's like very inconsequential, and you're just like people are having giant flame wars in the comments, and I'm like, this is you're all focused on like the wrong thing. And it's very common in our industry.
Given is that going to be amplified by AI? Just as a segue to some AI related questions.
uh I don't know.
Given the massive training set on existing code that has some baked in decisions into it, how do you think about this?
I mean, I think so. A lot of I think mistakes in API design have to do more with thinking overly much about how the code is going to look syntactically, as opposed to like what the edge cases are, what's allowed and what's not, like the foot guns and things like that. Uh, I think it's kind of too early to tell, to be honest, like exactly what um impacts like I mean, when we say AI, I'm assuming we're talking about large language models.
Yeah, I
So
mean
I'll
the
say
kind
AI,
of
but
the
that's what I
kind of
mean.
artificial information that gets baked into the production of code.
Yeah, I mean the reason I say I think it's too early to call is just that like I think if you asked me that and tried to pin me down on like making a concrete prediction, like right now versus like 3 months ago versus 6 months ago versus 12 months ago, you might just get multiple different answers. Because the way that like the models are changing, the way that people are experimenting with using the models is also changing, and like the tools around the models are changing. There are so many different variables that um, I think if you look back, like just to pick a number, like 12 months ago, like one calendar year ago, and you ask people about like, what are your predictions about AI, a year from now? Very few people, I think, would predict like exactly what the state of things is right now. I think you would find people who are like wrong in like lots of different ways and lots of different directions. So with something that specific about like what is the impact on like API design of AI and stuff like that, I think the most responsible answer is just like I don't know, and like I don't any speculation I gave you would just be like kind of shots in the dark.
That makes sense. And that's a perfectly reasonable answer. Um, does rock, for example, make sense in the age of AI, given that AI just tends to amplify already existing, I don't know, JavaScripts or Pythons or whatever? How have you thought about uh, in making rock get more adopted while also making it available for AI assistants and whatnot?
Well, I think I mean, it's sort of naturally available. It's actually already in, well, the uh the old syntax is in the training set. We made a number of
Hmm.
changes with like the new compiler. And so when working on the new compiler, a problem that I run into is like if I'm using an AI agent to like, generate some code or even like some like examples or something like that, it will use bits and pieces of obsolete rock syntax and I have to correct it. Like, no, no, that's not how we do it anymore. So that, that happens. But uh there's definitely a lot of speculation about like, are people still going to use programming languages? Are we still going to write code? Is code still going to be a thing? My prediction is that yes, code will still be a thing for the foreseeable future. Um, how far in the future? Who knows? At some point, do we get to a point where we talk to computers with our brains directly, and we don't even use like keyboards and screens anymore? Maybe at that point, do we still have code? I don't know. Do we have like some new thing that like just works neuronally instead? I don't know. That's like far enough in the future that I'm like, I'm not going to speculate about that. So I'm assuming we're still in the like screens and keyboards era, but we have large language models and they're increasingly capable and yada yada. Um, in that world, like what I concretely predict is going to happen, I don't know exactly the time frame. Like let's say like hand wavy next couple of years. Um, but I think where this maybe will settle out, assuming that large language models do not become super intelligent Skynet things, which I think a decreasing percentage of people believe is actually going to happen, like in the next 5-ish years. I guess some people are still maybe predicting that in like the next 10 years, but I don't know. It seems like they're really like plateauing in terms of like what they're capable of doing. As far as like super intelligence concerns go. Obviously, they're like getting more and more capable for programming tasks, but not for. I don't see Skynet like on the horizon. Even though like 2 years ago, people were probably like 2 years from now, Skynet, and I was like, well, it's been 2 years, still no sign of Skynet. Um, so I think from that perspective, there's a question of like, do humans need to look at code? So there's I think it's less controversial on the like, do humans need to write code? And I think certainly we can say at this point that's like optional. Like you certainly can, if you want, have a large language model synthesize all the code for you, and then you just read it or not, as the case may be. And like you don't need to actually like you can just use dictation, for example, and just only say English words and have all the code appear for you. Um, do you want to do it that way, or do you want to do it by writing the code by hand? I think that's like less interesting from a language perspective than the question of like, do humans read the code at all? Because there's certainly a lot of people who are saying, I don't read code and I just vibe code everything. I don't think they're vibe coding at work. I think people who are saying that, of which I like, I'm not saying that, but among people who are saying that, I'm pretty sure they're just doing it on like hobby projects. And I have not seen an example of like a really, I'm not even going to say good, I'm just going to say successful, like widely used vibe coded application other than that, like other than one which is like used by vibe coders for more vibe coding, if that makes sense. Um, and those seem to be like pretty experimental, and it's not like, oh, this is a big success story, other than like, well, you got a lot of people to try it, but like, but have they actually produced some like software that escapes that bubble of like people trying to build software just for this own use case where nobody's worried about the quality level? Like, have you seen any like apps on the App Store that are vibe coded that are popular? Have you seen any like, you know, uh, I don't know, like any businesses built on vibe coding? And you can make the case that it's too early, but for my money, what I kind of predict is that I don't think that vibe coding is like the future of the entire industry. I actually predict that some people will actually use it to make some apps that are some amount of successful, but that it's kind of going to be like the Amazon marketplace, where like if you go to buy stuff on Amazon, there is an unbelievable quantity of garbage out there. Like it's just there's so much of it. It's just like search result pages and pages of search results, and you click through and you're like, I can tell without even looking at the details, this is going to be garbage. It might set my house on fire, whatever. Like, I'm not going to buy that. I'm going to go buy one from like a more reputable brand than that. I think that's what like vibe coding is going to like do to software. It's going to mean that there's the barrier to entry is a lot lower. You can make software that works like at some level in a like for way less time than ever before. And so that means that you're going to have this proliferation of like a giant amount of stuff that's very low quality. Um, and then you will also have some software that's high quality that will stand out from all that, just like you do on the Amazon marketplace. And I predict that the high quality software is not going to be vibe coded. Maybe there will be exceptions, but by and large, I think that's software is going to be by people, however they're causing the code to get synthesized, they're going to be at least reading the code and understanding it and like and using that to like guide how the code base evolves and stuff like that. And in that world, I think yes, bringing it back all the way back to your original question, I think there's absolutely like then you're still in the world of programming languages matter. Being able to read the code and understand it and have a good mental model of like what it's doing and being able to like spot problems, being able to like read a diff, that it comes from another contributor or from a large language model or whatever, and like have something jump out at you like, no, 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 that's a problem. No, 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 stop, stop, stop. Do not go down that. No, we're not going to commit this because this is going to cause a problem. Or just like anticipating future problems and being like, this is going to be fine for now, but I can see just from looking at this code, even like your English summary of the code did not mention that there is a detail in here that's really going to cause problems down the line, and I'm going to prevent that problem by changing course now, based on like looking at the code. At that point, then like language matters and different things matter more than others, maybe than they used to. Like for example, it used to be a big deal. Like people would talk a lot about like be able to build X and Y minutes, right? It's like, oh, how quickly can I do that? And a lot of that is just about like typing, like how long are your variable names and stuff like that. Like how like, verbose is it to like get hello world on the screen? And now it's like, that's trivial. You just say like, hey, Claude, write me a hello world, whatever. And then it's like, there it is. So like getting up and running, that type of stuff is like not a big selling point anymore because like getting up and running is so trivial now. But being able to read the code and understand it and like not have gotchas and foot guns and stuff like that like littered around, that I think is like still very, very important. And so maybe proportionately it's actually more important just because the like getting off the ground, getting set up, getting things up and running has just shrunk, and so the other stuff has gotten more important, just by process elimination.
Is that principle baked into Zed, the tool that you're developing? So you're kind of treating, it seems to me, that Zed is treating AI as a tool that you control. Uh, where do you see the line between micromanaging everything and, as opposed to that, letting the agent go nuts? And how do you intend to add guardrails to what the agent is supposed to do in the code, not necessarily in the sandbox where you give it whatever dangerous permissions you give it?
Yeah. So I think those are two different questions. I think the guardrail stuff I think is more about it's not necessarily an editor thing. I think that's more of like a tooling thing. Like for example, in the Rock project, we've seen some common failure modes of like either mistakes or like stylistic things that we don't like that the agent will do. And so we've actually added some like lints that are explicitly like this lint is like not because humans make this mistake, but because AI agents make this mistake. So like put that in their feedback loop. So when they try to make this mistake, it'll just be like, no, 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 we don't do that in this code base. And so even if they do it on the first pass, then they like try to get, all the tests to pass. And then that lint trips and it explains in detail, like, here's why we don't do it and here's what to do instead. And then they go and fix it, and so the code base gets to stay in the state that we like. I don't think that's like a Zed thing, but philosophically, yeah, like Zed's philosophy is very much like Zed is aiming to be a tool for people who care about quality. It's like, AI is a tool to help you make high quality software. If you want to use it for something other than that, that's your prerogative, but that's not what Zed is designed for. So like we care a lot about the like if you're using an AI agent and then like what is the review process? How do you like make sure that you're understanding what the agent is doing? How are you able to control that process? We're working on features to make it so it's, easier for you to deal with like the sort of higher level stuff if you are giving the agent more autonomy, like having it like go churn on a problem, like how can you help with the like planning process and stuff like that, and like if you have multiple different things going in parallel, that type of stuff. But at the end of the day, it's like yeah, you're it's up to each individual programmer how much they want to care about quality, how much they want, like how much time and effort they want to put into that. um if somebody wants to just say like I don't care about the what code is being generated, I just want to like see pixels appear on my screen and so forth, and I don't care about the code at all, fair enough, like more power to you. But I think at the end of the day we will judge like as users of the software like what the quality level of it is, and that's kind of where the buck stops, is like do people actually have a good experience using it? Like, are there big security problems? That's a big conversation about that. Are there big performance problems? Are there lots of bugs, or does it feel like nice software? And maybe I will be wrong about that prediction, and maybe it will turn out that people are just able, the models get better, the tools get better, whatever. People are able to just only speak English, not even look at the code, and really high quality, non-buggy, secure software comes out the other side. I have not seen that happen so far, and I don't see a reason to believe that that would happen. But I'm open to being proven wrong about that.
How do you define quality software? So we've spoken about quality software from a few different perspectives. I was wondering how you define it, because because speaking of about vibe coding, Twitter is full of vibe coders publishing their apps they wrote in. They one shotted an app, they published it on App Store, and now it makes $1 million in like 3 hours or whatever. And nobody cares about what code was generated. Users, whatever, seem to like it. They download it, they use it, they whatever. How do you judge quality software, and how do you anticipate quality software is going to be visible to the user as well? And to what degree can it be hidden by, I don't know, nice UIs or whatever core functionality working?
Yeah, so I always think about three main things when it comes to like quality of software. So this would be performance, reliability, so like the absence of bugs, and I kind of like the third one I just think of as like user friendliness, which I would say is like the absence of frustration.
Mm-hmm.
So it's like if it's frustrating to use, it's buggy, and it's slow, that's not good, and quality is the opposite on all three of those dimensions. Ideally, all of them at once. Uh, so when it comes to like perception of quality, you do have a sort of a problem there of like first impression versus like long-term impression. So again, like maybe somebody who's like vibe coding these apps and like people are downloading them, like maybe they're like this is amazing, or maybe they're like I tried out the free version and it seemed to work well enough, and then I bought it, and then after I used it longer, maybe I ran into bugs that were annoying, maybe I didn't. Like maybe they're loving it, and maybe my earlier prediction is already wrong, and I just am not aware of these apps that people are making $1 million off of or whatever, and maybe they have lots of happy users, and could be totally wrong. Um, but yeah, I do think that that a lot of it is down to like perception versus like experience. Like you have it takes a certain amount of experience with something before you can really kind of get a like a solid picture of the whole thing. You can have a first impression of like, oh, this feels really slow right out the gates, or like I tried to do the most basic thing and it didn't work. That's like how you can tell, okay, well, this is like low quality. On the flip side, you also have some things where it's like, well, maybe the first impression is negative, but also not representative of the whole experience. I can definitely think of software that I've used where like initially I found the UI frustrating, but then I kind of got over that, and I was like, okay, now that I understand it, I actually like it overall. I still did have that negative experience. That's like, subtract some points for that. But like overall, the totality of the thing I actually really like. Vim might be a good example of this. Yeah, like happy user of Vim for a long time. At first, yeah, it was a pain to get into. And so I think on both of those cases, like to your question of like how do you sort of like how do you tell? Some of it is I think word of mouth. Like Vim was something that was recommended to me by a coworker that I trusted. Is like this is going to be hard to get into, but it's going to be worth your time, and I think he was right. And some of it I guess just ends up kind of being marketing. Like, can you convince people to give your thing a shot, and hopefully you are not incorrectly promoting it as high quality if it's not.
And a follow-up question: to what degree do you think these traits that you were discussing, so performance, reliability, and lack of frustration, to what degree do you think that they can be overcome by, I don't know, smart prompts or things like Claude, make this faster, make this accept a million queries per second or whatever?
Yeah, I think it depends on the application. So if you're doing something like, I mean, the two big code bases that I've had experience with, like since AI tools came out, are Zed at work. So that's a gigantic Rust code base, like 700,000 lines of Rust code, and Rock, which started out as like 300,000 lines of Rust code, and now the rewrite in Zig is at like 150,000 lines of Zig, something like that. So all of those are like big, very, very, very complicated code bases. Um, Certainly I have not had any success at like uh Claude make Zed fast. Well, Zed's already fast, but like if there is a performance problem, um I should caveat that with saying diagnosing the root cause of some performance problems can be effective. Like, so a thing that I have had success with is like, here's a flame graph, like figure out like why is this spike happening here. um that's like something that I could do by myself and just kind of like okay, go digging through the mess of code and like, oh, okay, this is an explanation that makes sense. I'm a big fan of using AI agents for that type of stuff because the answer they give me, like I can check. I can be like, hang on, does that make sense? Like you gave me an explanation in English. It wasn't in my head before. Now it is in my head. Does that make sense as an explanation for the behavior that I'm seeing? Um, so that's great. But then it's a different story to turn around and be like, okay, can you apply a fix for that? Now, I have seen some smaller cases where it's like, okay, this is something that was like, a really basic example is it's like, here's this thing that happens pretty often and it's kind of slow. Oh, we could add caching, right? Okay, sure. Like, yes, but like generally speaking, the thing that makes software like in the large be fast or slow either has more to do with like the problem domain. In other words, like, are you doing something that's just like innately fast, like no matter what? Or are you doing something that's sort of innately slow, like video processing, kind of no matter what on current hardware? Um, and then everything in between has more to do with like big picture architectural questions than it does around like individual, like, oh, just like go off and do a task to fix this. um if you are at a size of code base where you can just tell Claude, hey Claude, make the architecture be blah, or like find a fast architecture, do it. Great. But I have certainly seen that like just because the context windows run out, it's really, really hard, at least with the current models and current tools around them, uh, to get a model to just be like, I can just tell it, go switch to a fast architecture and it can solo that. I would expect Claude, even Opus 4.5, which as of this recording is like the best coding model in the world, I think uncontroversially. I would just expect it to make a giant mess out of those instructions. The amount of hand holding I have to do for like much smaller architectural changes than that, like in like Rock's compiler, for example. I mean, I give you an example. Like recently, we're porting over some code from the old Rust compiler. So this is actually like should be a pretty mechanical change, but there are some changes that some things that need to be a little bit different. One of the reasons we were doing a compiler rewrite in the first place is that we discovered an architectural mistake that we made that like has this really frustrating characteristic where it's like 99% of the time it's totally fine and 1% of the time it's unfixably broken, and the only way to fix it is to like redo the entire architecture of like this like multi-stage part of the compiler pipeline. Very, very frustrating realization, but one of several reasons that we decided to do a rewrite was like, look, we cannot like live with this now that we've realized, because we would get this like long tail of bug reports, and we were like, oh, we just need to like fix one more thing, and eventually we're like, this is actually not whack-a-mole. This is just like there is a fundamental problem here that is like we will never whack the last mole unless we actually fix the architecture. Um, and so, but like porting it over while being like, okay, we have this little like prototype of the new architecture that was written in OCaml like a couple years ago, that works and like demonstrates it, but is like not at all production ready. Only handles like 3 out of the like 80 use cases. That's a demonstration of how to do it right. Here's the old architecture. Just port the thing over, just right, just mechanically do the thing, and with the one caveat. And like I had multiple sessions of just being like, okay, do it like this. I spelled it out. I wrote like multiple paragraphs explanation. I reviewed the plan. I'm like, cool, the plan is good, and then would go off and do it. And like after a couple of like threads of context window exhaustion, and like picking up where it left off, I would come back and it'd be like, okay, I got to this point, but I'm having a problem in the interpreter. I'm like, interpreter? What were you? And it's like, yeah, I built a whole interpreter. I'm like, this is not an interpreter. What are you doing? Right. So like, and this is like me like working at a company that builds these tools. I like built the original like AI agent stuff in Zed. Like I've been working on that like the entire time. Like I don't know how you could have more experience, like professional experience working on AI agents than someone who's been doing what I've been doing for the last like year and a half. Because like stuff didn't exist like 3 years ago. And like now that it does, like that's what I've been working on. That's like been my area of focus at Zed. So I'm very, very familiar with the tools. I've used all the major ones like, Claude Code and like AMP and Zed and, all these different things. And this is the best model. So I'm like, when somebody, wants to come to me and act like, oh, you can just like, if you want to just switch architectures to make it fast, you just tell Claude, just go make it fast. And if it's an architectural change, you'll just do it. I'm like, I'm very, very skeptical that, it's that I'm holding it wrong. And that's the problem in this case. I think it's just like, yeah, no, like this is still hard. It's not, hey, Claude, draw me the owl. And, it draws you whatever shape of program you want with whatever performance characteristics and, reliability you want.
That's definitely been my experience as well. So it sounds to me that one of the major benefits of using AI in your workflow is that it helps you think more of a scientist, more like a scientist. I mean, giving you a potentially solid explanation, you test it out, and you see you see if that explanation fits with whatever you see and want to fix, and then go test them out, find a good one, and then once you have a good explanation, then you go implement that. Are there any other features of AI that you find particularly useful for productivity?
Well, I mean, there's all sorts of things. So I will say, I'm much more of an agent user than like an autocomplete user or something like that, or like an automatic like code review comment user, anything like that. I'm much more about like, I don't know, it's sort of like super chat where I'm just sort of like when I'm using like any kind of large language model to like make software work, I try to be very conversational with it. So it's like there's a lot of like, okay, I want to do this. Sketch me out a markdown document that's just like a plan of like what we want to do, and then I'll like go back and forth with it about like iterating on the plan. Like, okay, here's the plan. This is what we're going to build. All right, great. And then okay, let's start with like build this thing, and then I'm like, okay, let me stop. Let me try that out, and then let's see how it goes. Okay, and then at some point I'm like, okay, let me go look at the code, and I look at the code, and I go back to the model and say like, okay, here's my feedback about this code. Like this sucks. This is wrong. This is not what I want. Like this doesn't follow the conventions that should happen. Maybe I'll go and like edit some like agents.md file to like try to iterate with it and like and prevent that from happening in the future. Or maybe I'll say like, actually this whole thing, because this was like so little of my time, like just talking back and forth and like waiting for the agent's wall time or whatever, maybe I'll just be like, I don't want to do this whole direction anymore. Like this whole idea, like the whole plan I had for, like in my head for how I was going to implement this feature, I'm like, now that I've seen how the code looks, like I don't no, just throw all this away and I'll just like go start fresh with it. Like maybe I didn't intend for it to be prototyping, but because it was so cheap to have the AI write the first draft of that code, and I spent so little time reviewing it, I'm just like not very attached to it. So I'm like, yeah, now this process has revealed to me like a better direction, which is maybe less scientific and more just sort of like the typical iterating towards quality thing that we do in software, just like accelerated, because I didn't need to like actually type out every keystroke to get to the implementation that made me realize that I was going in the wrong direction the whole time. That's another use case I like. Actually, bug fix reproduction is one I'm a huge fan of. So ever since advent of code, we've gotten this like very steady stream of like small bug reports for Rock, and it's not like, oh god, we got to like sit down and rethink blah. It's just like, no, like the error message here is like a little bit wrong, or like I did this followed by this followed by this followed by this, and the compiler crashed or something. or like the compiler gave me a type mismatch here, but I don't think this should be a type mismatch. Um, so I have this little like script that's just like a slash command in Claude Code that's just like we're adding slash commands to Z actually. That's I was just working on that last week. Um, but basically it's like I just tell it like, look, here's a GitHub issue. Here's what I want you to do. I want you to go figure out how to reproduce this issue in a test. Um, the test needs to like I gave it some criteria around like the most extreme test is like an integration test that like spins up the full compiler, but those are expensive. So like try to reproduce in like a cheaper test, like a unit test if you can. Make sure it actually reproduces. Then like commit while it's like still failing. Then go try to come up with a fix, apply the fix, confirm that the test no longer fails without having changed the test, etc. Make a draft pull request and there's like one other thing that I haven't do. But anyway, oh yeah, then like babysit CI until it's green because sometimes it's like maybe it'll flake, so I can use the like a command to like tell it to restart. I give it like a little bit of access to like GitHub permissions for that. And basically, so what's great about that is that a whole lot of the work of dealing with like random bug reports is just like, okay, I got to go reproduce it. And as soon as I reproduce it, I'm like, I want to write a test that reproduces it. Once I do that, then I'm like, okay, now I can go look at the fix. Then after all of that, then I'm like thinking about like, okay, I found a fix. It fixes that thing. Is this a good fix, etc.? Is this like the right fix? Is there like an underlying problem here? And the what's great about this is I just with almost no effort, my process now starts with it's almost like an external contributor gave me this pull request, right? But it's not an external contributor, but it is like, okay, here's the bug. Here's a test that reproduces the bug. Here is some code that purportedly fixes the bug, or at least makes the test case pass. So now I can look at it and be like, okay, is this test case like too narrow? Is this a band-aid fix? Is this like an actually good fix? And like using my own judgment to be like, is this the right fix? Is this the wrong fix? Is this like, is this actually maybe indicative of a more serious problem that like, yeah, this is going to fix this, but now we're just going to be fixing another one very similar, but like in a slightly different part of the code base later on. And I can sort of start with the more interesting parts of the bug fix rather than the sort of the chore of like, okay, reproduce it. Yep, reproduced it. Okay, make a test that reproduces it, blah, blah, blah. Like all that stuff that's sort of like not interesting to me after, 30 some odd years of making software. Whereas the questions about like, what are the implications of the fix? Is there a more serious thing here? Like looking at it more analytically, getting a start from that is great. It's a big time saver.
Do you anticipate this will be the main use case for using AIs in your own workflow for the foreseeable future, or do you anticipate fundamental changes to that?
As in like talking back and forth with agents
Yeah.
or
Yeah.
that's a good question. I don't anticipate. I guess what I would say is I don't anticipate something else. Like I can't point and be like, I think it's going to be this instead of that. That's not to say that I feel a lot of confidence that like this is going to be the thing. Because I don't know, like this stuff changes pretty quickly. Like a year ago, it wasn't agents at all, and now like that's what I'm using, exclusively. Like a year ago, we were talking a lot about like AI assisted autocomplete, or like tab completes, like tab was like the meme a year ago, and now I don't even use that at all. I mean I used to, but like now I just like, no, I'll just tell the agent what to do instead. And so because of that, I just feel pretty low confidence about predictions at that level of like
Right.
what is it going to look like. I feel more confident about predictions about like broad like are people going to be using code or not, and how much, and then I do it in things like that. So yeah, I don't know. Is it still going to be the future? Maybe, but if it's not going to be the future, I can't point to something else that I think would replace it.
Understood. I think that's a reasonable answer. Um, Richard, I want to be respectful of your time. We already went past the initial scheduled times, and I wanted
All good.
to say that I appreciate that. I wanted to finish up with maybe a more personal question because you strike me as a very high energy person, and I wanted to ask how you maintain that. So you're a very clear speaker. You obviously have lots of insightful ideas, and I'm gonna walk out of this little studio with lots of notes. Um, how do you maintain this high energy building whatever you're building? So you're building a programming language that you want to be more popular than Go, which is a major project in and of itself. You're building Zed, which is an AI-enabled dev environment. This is also a big project. You're also teaching. You're a conference speaker. You're doing a lot of things. How do you balance your energy and how do you keep it alive?
I mean, this is not also not something I think I have advice on. I don't know. This is sort of how I am. I mean, it helps definitely like having other people working on these things that are excited about it. Like, I mean, Rock is something that like I started, and other people fortunately are now working on it with me, and they're awesome, and I enjoy like talking with them and like feeding off that energy too. Um, Zed obviously is not something that I started. I just joined and I'm working on, and I feed off their energy too. Like they're all excited about building a really high quality product too. And so I would say like if there is something that like makes me feel motivated, it always comes down to people. Whether it's like the people that I'm working with to build the thing, or getting back to what we were talking about earlier about like what sort of like drives me at like a core level is just like just being excited about like somebody else is going to use this and they're going to have a great time with it. That's always been just intrinsically motivating for me. So, yeah, I mean, as long as I'm working on stuff that I think other people are going to enjoy, and I genuinely believe that they will enjoy it, then that's kind of all the motivation I need.
And I think that's an amazing place to wrap up. I think this is food for thought for the audience listening. Just work on interesting projects that will give you internal motivation because that will sustain you for much longer than any sort of other extrinsic reward, like I don't know, the usual, money, fame, whatever. Um, so, Richard, thank you so much for all the insightful ideas and for your perspectives. I'm definitely going to take away a few lessons for myself as well. And for
Awesome.
everybody listening, you're going to see this on all platforms where Rock the Code is active. And until next time, thank you for listening and watching. Richard, thank you so much for your time.
Yeah, thanks for having me. Nice talking to you.